All right, folks, what we're going to be doing today is writing equations of transform functions. Here we're going to be dealing with specifically today are transforming radical functions. So if we look using Desmos.com at a couple different things, and you could use a graphing calculator if you want, but this is our original function. This is the shape we're given. This is our original or parent function, and after some playing around with Desmos or a graphing calculator, we will find out that this is going to be the cube root of x. So we can see here that this is my point where everything changes. Here, you can see it's going up, and then it has another change here. My point of change in the transform function is going to be right here. Maybe a little bit difficult to see in this red function, but that point is -2, 3. So since this is the point that's been changed, we could tell that there's been some kind of a shift, okay? And if we remember, we're shifting to the left, that means it's going to be inside, and we're shifting up, which means it's going to be outside. So far, what we're dealing with in our transformed function is we're going to see we have, I'll call it g of x, and it's going to be the cubed root of x. This is -2, so inside we're going to be actually adding this, +2. Then on the outside, we're going up 3. So the only other thing we need to change or check is see if the function has been stretched or not. I know that my drawing is not exactly perfect, but we can see that if we were to shift this to the right 2 and down 3, it would lay on that perfectly. So the transformed function, again, what I did is I looked, first thing I did was look to see this point where everything changes and determine what that point is. This will tell me if I have a translation. And if it's the same point, it wouldn't be a translation. It would just be shifted if it was a little bit wider or narrower. So the transform function is going to have the equation g of x equals the cubed root of x plus 2 and then plus 3.